Hello, my name is David Weaver, and that's my dog. And every time I talk, he likes to bark. So say hi to Lembo, wherever Lembo is. So, anyways, I am your guide here on all things engineering for this semester. And so I welcome you. I wanted to spend a few minutes just telling you a little bit about me and some of my philosophical kinds of backgrounds that may or may not have come through on the syllabus. And so, um, starting at the end, working forward, that this is my 40th year teaching in Maricopa. Um, this is the seventh college I've been to, not because I couldn't hold a job. Um, I started as part-time faculty at what is now Gateway Community College, and then I was hired by Scottsdale Community College to put together an electronics microprocessor technology program. My background's in physics, but I've done semiconductor stuff, so it kind of worked out. And then Chandler Gilbert opened up about the same time Paradise Valley opened up, and I moved down there where I spent 25 years primarily teaching physics, but along the way, Intel came in with their Ocotillo plant, and they needed semiconductor manufacturing technicians. So I put together an SMT program and ran that for a bit. And then after 25 years there, in the previous time at Scottsdale Community College, I decided to retire. And so I retired in 2014, became emeritus faculty and all that happy stuff. And that lasted about a year. My wife knows how to retire. Didn't work so well for me. So I started looking around, and a friend out at Estrella Mountain Community College was going on sabbatical. And so he needed a replacement for a year, and we taught physics very much the same kind of way. And so I went ahead and agreed to be his replacement. And getting towards spring break of that year, I realized I was having fun, and he was coming back, so I didn't have that gig anymore. Or I wouldn't. And so I asked the president, do you have anything else that you need done? And they just received a grant to put in a makerspace. And you'll learn more about that in these classes. But it's a place where you go to make stuff, typically containing things like 3D printers, laser cutter etchers, vinyl cutters, sometimes wood equipment, all kinds of things. So I put together what I called the steam engine at Estrella Mountain Community College, which was a two-room makerspace, one that was the dirty end with all the wood things, up to and including a 4x4 wood router that could also be converted to a plasma table so you could cut metal. While I was there, we didn't do that because of fume mitigation, because cutting wood is one thing, cutting metal is another. The other room had several 3D printers, including one that was pretty huge, like a meter by a meter by a half a meter in terms of the print bed, plus others. It had a laser cutter etcher, vinyl cutter, sewing machines, that kind of stuff. So I ran that for 3 years. And then last summer, I was done at Estrella, and Paradise Valley asked me, would you put together an engineering program? Now, it turns out that engineering has been taught at Paradise Valley for 2 decades, but it's been pretty much just ECE 102, 103. And every time they tried to hire somebody to actually get a program up and running, it just didn't work out for a variety of reasons. And so I figured, you know what the heck, I'll give it a shot. So I started giving it a shot last year. So that's when that happened. The first semester, I just taught what was already scheduled. And then in the spring, I set everything up on 8 weeks. I call them semesters, that I'm sure you've looked at what's required for your curriculum. And if you start off even completely prepared, ready to take Calc 1 when you walk in, you're still looking at close to 3 years to get through everything due to the prerequisite chaining. And so what I had done successfully with the semiconductor program is put that into a semester environment so we could move through the prerequisites. And so that's what I did. So you could take 102 and 103 in a single semester, or 211 and 212 in the same semester, rather than having to spread those out over 2 semesters. And my goal would be to have the summer be another semester, so there'd be 5 of those in a year, rather than you having the ability to take 2 courses or maybe 3 in engineering, or at least those that are in a prerequisite chain in a given year. So we started that, and then, COVID hit. And so spring break was when we were going to switch to the second semester. And, we were locked out of campus. Luckily, I was able to get in and still work in our high-tech lab where we've got 5 workhorse 3D printers, and with some student assistance, and then a lot of assistance with the students in the computer commons, we're able to produce 360 face shields, PPE, personal protective equipment, and then ear savers, which are straps that you put behind your head, and then hook masks over it to make it a little more comfortable. They're called ear savers. So we did 400 of those. So the 360 and the 400 we sent up to the Navajo Nation, and then did 150 of the face shields for U of A Med School, and then numerous other kinds of folks. So we were able to do some cool stuff. However, it wasn't what I intended. As you know from looking at the syllabus, that I am a big fan of project-based things. And so it was a little hard to do that on the fly. And this semester will be better than last semester was, but still we're having to build this as we go. Some people talk about, well, it's like building an airplane while it's flying. I don't know if it's that radical, but we are going to have to work on things as we go. As to my background, youngest of 6, born in Massachusetts, lived in Ohio, moved to Texas the summer before my sophomore year in high school. I went to high school in Texas, then went to college, got bachelor's and master's in Texas. Undergraduate, I had physics and English as dual majors, math as a minor, and then grad school, I got a master's in physics. I didn't quite finish there, though. I'd started a couple of businesses and then got a partner, and we decided to move out of the small town in Texas we were in and moved to the big city, Phoenix, where my brother lived, so we could grow our business. But after a while, just the pursuit of money was not enough for me. It wasn't the intellectual challenge that I wanted. So I started looking for other things to do. I started teaching at what's now called Gateway. At the time, it's called Maricopa Tech. And then I got the job at Scottsdale Community College. And then from afar, I finished up my master's. And that got me going where I'm going. Now, in full disclosure, I haven't had an engineering course in my life. But I would argue a couple of things. One thing I would argue is that engineering is just applied physics. And the best physics is always applied physics. So in many respects, I've been doing engineering as I've taught physics for the last nearly 4 decades. The other thing is that I've worked as an engineer, that when Motorola, which used to have a huge presence in the Valley, decided to start their quality control, their total quality management program called Six Sigma, I was one of their first corporate trainers, teaching people the importance of using statistics to control processes. And so I did that work for them while I was still at Scottsdale. And then I'd mentioned that I started the semiconductor program at Chandler Gilbert for Intel. And I worked with them multiple summers. So I worked as a defect reduction engineer. I worked in their device physics labs where all chips that had died went to get figured out why they died. And so I've had some engineering background. And so, it's something that I don't want to be cocky or anything, but with a solid physics background, you can do lots of things. Because I know when I first started looking for a job, when I decided that I didn't want to be a big businessman anymore, that I was able to interview for many, many different types of engineering specialties, because I have the electrical, mechanical, optical, electrical, computer. I had lots of different backgrounds. I did get a couple of offers as a microprocessor engineer because I learned about microprocessors in college, and this is when they first came out, so not many people knew about it. So anyways, I feel like I've got the background. One other area of, I wouldn't say concern, but again, in full disclosure, that I spent probably 12 years as the chair of the Maricopa Physics Instructional Council. Each of the disciplines within Maricopa has a council that's responsible for the curriculum. And that means what courses are offered and then what's supposed to be in each of the courses. And so one of the things that happened early in the 80s is everybody was told you have to make your courses competency-based. And what most disciplines, including physics and then especially engineering, what they did is they grabbed a textbook, and for the course outline, they copied the table of contents. And for the competencies, they took the major headings of each of the chapters and put an action word or a phrase in front of it. Like, students will be able to describe Newton's 3 laws of motion, where there's really 4, but we'll stick with 3 for the time being, which they're not meaningful. Competencies are skills that you should get from a course and be able to use. And that last part is where most courses fall down. Now, you have looked at the course competencies, I assume, because you've looked at the syllabus, and they're front and center in the syllabus. It has both the official competencies and the official outline. And then I have included a few additional learning objectives that I'd like you to have. And so if you're in 211 or 212, you'll see that they are primarily mathematical in nature, and one would be hard-pressed to describe how practical that is in terms of, as an engineer, are you going to do those things? And that's one of the first discussions you're going to have is mathematics and real engineering. What I was able to do in physics as the instructional council chair, and it took me nearly a decade to do it, is to change from the 30 competencies and 125 outline elements to 4 or 5 competencies and 5 or 6 outline elements, where the competencies are skills that are really useful, and then the outline elements are broad categories of things. So if faculty want to focus in on a particular element of that outline, they can. When I started doing engineering at PV last year, I joined the Engineering Instructional Council, and we went through and modified the Engineering 102 and 103. So if you're in Engineering 102 or 103, that you'll see coming up that the competencies are much more meaningful and the outline is quite a bit shrunk. So I'm not a big fan of hammering the math part. That I think you need to understand the concepts behind various mathematical operations, but you're not going to be cramming and jamming lots of problems in here. You're going to do what's necessary to show that you have a competency. So you will have an example or two that you'd be able to say to a future faculty member that the course you're in might be a prerequisite for. Do you have the skill? And you can say, see, I did it. And you'll be at least as far ahead, in my opinion, as somebody that did the cram and jam of lots and lots of problems. And then they get to the end of the semester and don't remember squat. Projects provide a context for you to learn the content in. However, and especially the 211 and 212, the required competencies don't lend themselves to practical application very well. So I have chosen a couple of projects that I think are interesting that are in the realm. So, for example, in statics, that you're going to build a bridge where there's lots of static stuff going on. And you're going to use some of the tools that you learn in content to help analyze and describe the statics of a bridge. But it is not as smooth a way of integrating things like in physics. It's easy for me to make projects and focus on the specific competencies. What else to say about it? The second project in the statics course is I'd seen a video, and you're going to watch the video of the building of the Great Pyramid. And so you're going to become a pyramid builder. And again, I hope they are interesting projects for you. What else do I got to tell you? That please call me David. That I want to make myself available to you. That in this kind of environment, we're going to be using WebEx, and then specifically WebEx Teams. And I'll be able to set you up in Teams once we've selected Teams so you can meet on your own. But then during the week, I want to make myself available for one or more class meetings. So if you as a group want to come in and we can talk about what's going on, and if there are questions about any particular competencies or about the project, we can deal with that. Within WebEx Teams, there's also the ability to set up office hours so you can sign up for specific times so we can have one-on-one conversations. I also got permission for you to be able to come in twice during each semester to the high-tech lab. This initially for the first course, so for those in 211, 212, for 211, we're just going to focus on 3D printing. And you're going to learn 3D design and how to slice it, etc. And then we'll get your first projects printed for you. But you being able to come in and see the printing going on and see what's involved is something I think it would be excellent for you to have as an experience. Now, I do know that this is an online class, so you are not required in any way, shape, or form to show up for class meetings, for office hours, or to the high-tech lab. And so if your schedule or your comfort level with being around a bunch of people, well, we're going to be practicing social distancing, etc. when we're on campus. We'll have to go in waves so that we don't have too many people in there at once. But if you're just not comfortable with that kind of thing, there will be no penalty. I will attempt to record all of the class sessions and post them on Canvas. And then I'll record some portions anyways of any visits to the high-tech lab. So again, if you weren't able, or if you're not able to participate, you'll at least be able to see what's going on. Anything else I can think of? The other thing I can think of is I'll just speak to the 211 at this point in time, that a student last semester in 211 found a video resource of a professor that has, 60, 70 videos about statics. And teaches it. I mean, he's very lively and, he's great to watch, but it's more, traditional lecture. Here's board work. Here's how you do these things. And so I've provided you with that resource. And then there's a 600 plus page PDF of a textbook that's a traditional textbook for statics. And so what I've done is, for the 10 course competencies, I've split those up over the 8 weeks. And this is again for 211. And similar things will happen in the 212 and 102 in the second 8 weeks. That I have competencies that I've identified, but it's not necessarily linear with what the videos are and what the textbook has. I'm not going to lecture about those topics because that material is out there for you. And there's no reason in my mind for me to reinvent the wheel. And in fact, I think COVID is showing a lot of higher educators that why do we charge for what we do? Because you can find most of this stuff the way it's taught most places online. So why would I go to an Ivy League school, for instance, or even, I don't know, like ASU, to have somebody do, especially if you're doing it online with them, what's the value added? So I'm hopeful that you getting a lot of the content stuff from materials that are already available, and then me adding discussions, neat resources, projects, interviews, and work with the high-tech tools are the value that we're adding that make it more worthwhile. Now, is it worth what we're charging? That remains to be seen. But that's kind of where we are with that. So I think that's all that I really wanted to say at this point in time. I just wanted to sort of give you a bigger view of me and the course, and possibly spur questions. So you can use the communication features within Canvas to reach out to me. That once we fire up WebEx next week, which I'm doing this the Friday before classes start on Monday, when we fire up WebEx, that you'll be able to ask me additional questions about anything. But, if anything I've said in this video piece prompts you to ask questions, all over that. So again, I'd say to you, thank you very much for deciding to participate, choosing Paradise Valley as your place to be, and me as your instructor. So I'll see ya. Bye-bye now.